and also networking security. Thank you very much, sir, for your sparing valuable time. Even you are
pleasure,
in
madam.
a very
Pleasure, madam.
busy
Pleasure. Thank you.
schedule. Thank you very much, sir.
Yeah,
Thank
thank
you.
you.
Dear participants, now welcome to the session 4, Scientific Computing and Experiments. Screen is visible. Dear participants. As students, as time is running out, I'll start the session, that is Scientific Computing and Experiments. Students, we are focusing on the main basics. Okay, directly we'll go to the session. That is, what is scientific computing? It is nothing but the application of computational methods and tools to solve complex scientific and engineering problems. So, in daily activities or in our real time, we will face many complex problems. And nowadays, we are enjoying the technical advances. So, for all this, the backbone is like scientific computing and advancements in electronics and different technical era. As we are living in the technical era, we are taking the applications uh, to in our daily life. So this scientific computing involves the mainly it involves algorithms, simulation, mathematical modelings, and analysis, interpreting data. All these are comes under the scientific computing. Here the key features are mainly like problem solving, which uses computational techniques to tackle the problem which are very difficult to solve by using our normal skills. So here means to solve the difficult problems, generally we will use this type of scientific computing, means our real-time applications. And second one is simulation and modeling that creates models to simulate our real-world phenomena such as climate patterns, biological systems, or material behaviors. And then data analysis, so to analyze the large data sets, so now we are dealing with GBs of data, terabytes of data. So to analyze all these data for our real-time applications, these methods we will use. So, in the scientific computing, the backbone is Internet of Things. I think this is a recent buzzword in 20th century. You heard means you heard a lot regarding this IoT. What is IoT? That is Internet of Things, which refers to the combining real-time devices with that is like sensor softwares, everything with internet to collect, share, or act to interpret something depends on our requirement, depending on some programming and everything. Okay. So here the core components of this scientific computing are the Internet of Things is like IoT devices, that is like sensors, cameras, applications, network which enables communication between devices and platforms. Being first year students, you know that about internet and everything. So this is only an keeping in mind that you are a fresher and you have to know the basic things. Just I am telling that what are the core components. And the third one is data processing unit. That processing unit like microprocessors, controllers. So in many applications we will use processors and controllers. Like even you can take the application like our daily what we computer. That computer is nothing but CPU. CPU is nothing but microprocessor. So there is a difference between CPU and microprocessor. CPU is a discrete device, whereas microprocessor or controllers are integrated devices. So if you replace your CPU with these integrated devices like microprocessor controllers, they are microcomputers. In nowadays, we are having much applications with these computers, and the devices, they're handheld. Computers also we can make there because by using like Arduino, Raspberry Pi. These are application specific integrated circuits. They are having interfaced with some peripheral devices to make use of uh, designing the real-time applications, and also cloud platforms to analyze and store, because in our systems we cannot store much data. So for that we can take the help of cloud platforms available. And I think you all know the applications, whatever the real-time applications that we are enjoying in our daily life, that is smartphones, smart homes, healthcare, even the phones in agricultural, some smart irrigation systems, optimizing water usage. And the next step like for Internet of Things is industrial IoT, that is IIoT. These are all even in smart cities also. We are smart cities means for traffic management, waste management, and in energy optimization and everything we are using this IoT, that is embedded with the scientific computing. Uh, So this is nothing but IoT with the scientific computing. In this IoT is having many benefits. We are combining when we are combining IoT with scientific computing, we will have real-time data collection enabling enhanced decision making, automation and scalability, integration of machine learning algorithms. Already we are having some sessions on AI, and to get the cost effective solutions for all these, we can integrate that IoT with the scientific computing. And these applications, as we are having energy management applications like this. We are having many applications. And here this figure shows yes, the figure shows that this is a center. We are having a AI activated IoT, and many devices are connected, which are in our real time applications. So when we are combining IoT with scientific computing, which complement each other by bridging the gap between real world data collection and advanced computation analysis. So these IoT devices will provide continuous real-time data while scientific computing process the interprets the data to solve complex problems. Okay, this is an overview of architecture of IoT. Just you see here, we are having sensors, actuators. Just a minute. So this is nothing but architecture of IoT. This figure shows architecture here. At the three steps we are having the edge, the network, and the cloud. See here in the edge we are having sensors, actuators, controllers, which forms the logic for our requirement. And this internet and cloud will use it for data storing, analyzing, for security purposes, and everything we will use this. Here, the HMA is nothing but human machine interface, means which connects the physical devices with the internet. Okay. So these are the components of scientific computing, of IoT for scientific computing, that is sensors, as we have just now seen in the picture, and microcontrollers and microprocessors, Arduino, Node MCU, Raspberry Pi, all these are the popular processors and controllers. And if you can see the examples of these are the devices, I have said, no, my Arduino, this is one handheld computing board. Similarly, ESP Node MCU, which uses ESP8266 and Raspberry Pi. All these are the advanced uh, devices which connects the physical devices to the cloud and internet to form a real-time application, or we can design real-time applications by using all these devices. Okay. Then these are the applications. As we want to show some experiments in real time to you, I'm not taking much time to explain everything. We are having so many apps and software, freeware softwares to design the circuits, like many means like multi-sim, and we are having some Android applications and Tinkercad, all these applications we can use to implement our designs before developing with the hardwares. So hardware devices working with directly hardware devices will consume money and much time. So before implementing on the direct hardware, we can use this type of software or apps to implement by using implement by circuits implement in software, and then after getting required output we can design the same application in real time. So for that we are so we are explaining, we are going to explain some hand-on exercises like LED blink, button control, and sensor interaction, and some live examples we want to show you. Be tuned, and these examples, to run these examples by using Tinkercad. Our resource person Satish from Assistant Professor of Centurion in the Department of CSC is uh, in online. So over to you, Satish sir. Please welcome.
Thank you, ma'am, for giving this opportunity, and thanks to JNTUCB. Okay. So, good evening, students. So, now I am going to explain some of the problems by using the IoT. See, In IoT means Internet of Things, as ma'am told earlier. So we will integrate this IoT in our everyday life. So if you see an example like your iron box, simple iron box. So what it will do, it will automatically shut off when it reaches a certain temperature. So basically IoT is defined into two types. First one is sensing and second one is manual. Sensing means when it reaches to a certain condition, automatically it shut off the powers. So like if you see when you are entering malls, so what it will happen? So when you are nearby the doors will automatically open. There they will place some IR sensors and ultrasonic sensors. So by using these all sensors, we can easily automate the what are the things we are using. We can easily automate by using these sensors. So I will tell you a simple example. I hope my screen is visible. Yeah. See, you can see it is a Arduino, it is a one type of microcontroller. So basically in our students projects, we mostly use three types of controllers. That is Arduino Uno, and another one is ESP8266, and third one is Raspberry Pi. So I will tell you just one line regarding this, what are the differences between these controllers. So initially Raspberry Pi will tell you regarding the, it means if you want to do some normal projects, you can easily use Arduino Uno. So when coming to the ESP8266, that is nothing but Node MCU. It contains a built-in Wi-Fi module. So if you want to transfer a data from one device to another device, so it should we need to connect to the internet. So in the Arduino Uno, they won't provide any Wi-Fi modules. So we need to connect an external Wi-Fi module to the Arduino. So, so in ESP8266, there is already in a inbuilt Wi-Fi module is there. So by using this, we can easily directly connect it to the internet by using the Node MCU. See, let's see. I will show. So you can see my screen. It is a small example that the blinking of LED. Okay. See, this is the Arduino board. I have connected one LED, and also these are the wires, and this resistor is used to decrease the power, and what is the power required to the LED that it will gives to the LED display. See, when you start to write this code, we want a Arduino IDE software. So this is a online virtual platform which is used to do some small projects without having hardware. You can easily do these projects by using the software. So simply it is Arduino board. I have connected a LED, and one node is connected to the ground and another one node is connected to the pin 13. So you can see we need to write a code for this. See, in this it is a C++ code. See, I have written the pin number 13. So that means I need to, the data will be sent to the LED by using this pin. So once we write this code, so when we start simulation, then so when we start the simulation, see, you can see the LED is blinking. But see what I have written the code. So delay is 1 second, means it will lights up the, for every 1 second it will this shows the code. So like that we will use different types of sensors and actuators to do several tasks. So I will show you another example. See, this is a security system. So that means this is a PAR sensor. So PAR sensor means it is like so basically it is one type of IR sensors which emits light waves when I will start simulation. See. So this is the range of the PAR sensor. So like when the person is entered, see, the buzzer will be give some sound, and also the LED will be blinks. So that means, so this is the, you can see this is the range of the PAR sensor. When a person has entered into this area, see, so automatically the buzzer will rings and also the LED will be glow on. So by that we can easily identify as someone has entered into our place. So it is mostly used in our homes or in some industries and somewhere. So because when a person has entered in this area, so automatically the buzzer will be gives some sound, and also the LED will be blinks. So like that we can develop a different types of projects by using this all these sensors. So initially the main components of the IoT is sensors and actuators as well as the microcontrollers. So sensors is nothing but the which is gives the input to the controller. See, means you can see this PAR sensor. So what it will do, so when a person has enters, it automatically sends the signal to the controller. So once the controller has received the signal, then it automatically gives the buzzer sound, and also the light will be blinks. So it will become say it has a it will become a actuator, because when a person has entered, we can easily know by using this system. So like that, we in the real world examples there will be different types of real world examples are there. So like in environmental monitoring, and as well as the retails, and transport, and smart homes, smart cities, like that. See, in environmental monitoring, the IoT devices plays a crucial role. Like in if you want to test a water, whether it is good or bad, so what we will do, we simply put a TDS meter or pH value meter in that water, and automatically the value will be displayed on that certain point. And also for air quality monitoring, we use some sensors like MQ2, MQ3, like MQC series. So these all sensor is used to identify the which is the whether the air quality is good or bad. So you can see in nowadays in Delhi, and the most of the popular cities having facing the low air quality index. How they will know? Because they will put some, so they will put some sensors. So by using these MQT sensors, what they will do, simply they will analyze the gas. So whether it is the the percentage of the oxygen, percentage of the nitrogen, carbon monoxide, carbon dioxide, there will be different types of gases are there. So by using these MQ series sensors, they they will know the what is the air quality index. So and also in environmental monitoring, we can easily get the weather updates. So when you open your mobile app, there will be mentioned that this is the temperature and this is the humidity. How we will know? Because of there was a sensor called DHT11 sensor. See, you can see this is the DHT11 sensor, which is having a thermostat and the humidity. So this sensor collects the humidity and temperatures in the at certain condition. So it will these sensors will be placed in different types of places, and this will be the readings will be, so the readings will be displayed in the see, I will show you. I will show you one architecture. See, you can see the architecture of IoT. So here what it will call. So this is the main architecture of that. So this means the edge. So in the edge, what it will have, there will be a different types of sensors, actuators, and will be and the controls. So let's take an example of the weather forecasting system. See, in weather forecasting, what it will happen. So the weather, there will be a different types of places are there in our cities, and like that in our districts are there. So here what it will do, so it collects the weather data from each and every field. See, in your when you open your weather app, you can see the temperature and humidity of a in New Delhi and also Visakhapatnam. So you can see different types of places. You can easily identify what are the temperatures and what is the humidity. So everything will be there. So what it will do? So let's take a. It is a. Let's take this is a city A, and this is city B, and this is city C. What it will do? It initially collects the temperatures and humidity. What are the conditions there in that certain place? So this is the edge means it will only collect the data. So here we call as a HMI. HMI is nothing but human machine interface. So HMI is nothing but it acts as a bridge between as well as the what are the devices all are connected here and well the internet. So see, when you open a app, so it will see here what it will happen. So initially these are the different types of places where the weather data will be collected. See here, so let's assume this is a city A and city this is city B and this is city C. So all this data will be stored in the cloud. So with the help of the network. So here HMI means so human machine interface. So it is a system that where we can operate the see in that weather station what it will, we will get the different types of inputs like temperature, humidity, air quality index as well as the wind speed and everything. So this HMI is used to display the what are the data is collected from these sensors and it will shows the display will be here. So it's like a interaction between the humans and the machines, and this is the edge gateway. So edge gateway is nothing but like our routers and the cellular networks, so like that Wi-Fi routers. So what it will do, it connects the data from, so what are the data which is collected from these all these cities will be sent by using the network. So you have seen the network, there will be different types of communication technologies. So mostly we will use the internet only. So we can, where we are with the internet, we can easily access the internet by using like Wi-Fi routers and the cellular networks. So once it is connected to the internet, it automatically sends the data to the cloud compute and storage is nothing but the cloud. So you can hear the word the cloud. So cloud means it will store the most of the amount of data. See, you can, when you open your weather app, so you can easily say that for the next day, and it will say that what is the sunrise and what is the sunset. How can they know? So these all these sensors, what it will do, so all this data will be uh, stored in the cloud. So by using these data, it will
See. Am I audible, guys? Am I audible? Okay, listen. So here we can see different types of places where we can connect these IoT devices. So this is a wireless connection. Means in a hill areas, what we there will be no internet and there will be a no. What are the we no need to place the weather stations. By using wireless technologies, we can easily collect the weather data by using these wireless technologies. Okay. See, these are the three types of processors. So this is the Arduino Uno, as I said earlier. So this is the ESP8266 Node MCU. So we can send the data by using this node MC directly. It will connect to the Wi-Fi. And also the Raspberry Pi, it is used for the most complex problems. So if we want to upload a code, so for ESP8266 and Arduino, we need a software called Arduino IDE. For in Raspberry Pi, what we will call it acts like a micro controller. So we no need to add any softwares. So we can easily, you can see these ports. So we can easily connect the USB. By using the USB ports, we can easily connect the mouse and the keyboard, and also we can directly connect the Ethernet. So we can also get the output by using this micro HDMI ports. See, so see, there will be some micro HDMI ports. By using these ports, what we can directly connect this to the computer or like a monitor. So we can easily write the code in that only. So it works like a mini CPU. So like that we can easily use these IoT devices in a various manners. So I will show you one real world example like a weather station. So in weather station, what we will do, so it collects the temperature data and humidity data and wind speed, everything. So I'm already said about the DHT11 sensor, which is used to detect the temperature and the humidity. See, I will show you. See, the node MCU processor. So what it will do, it works as a controller. So you can see the temperature readings here. Okay. So temperature. See, you can change the, if the temperature has decreased or increased, then automatically it will show the temperature and also the humidity. So by using this, you can do different types of projects like machine learning, and you can add machine learning algorithms and cyber security algorithms. By using these algorithms, we can enhance the IoT into a higher version. See, here I have used a DHT11 sensor. So it collects the temperature and humidity data. So we can also add different types of components for this, and it can be displayed to the LCD board. See, this is the DHT11 sensor. So if any electronic component should be work, so it need to a power supply. So it comes a ground and VCC as well as the data. So initially it sends the power supply, and also what is the, by using this wires, so automatically this process will collect the temperature data. So and that temperature data will be stored in the cloud, and also it will be displayed in the LCD board. So like this, there will be a different types of IoT applications by in our real life, and also smart homes, smart cities, as well as the Wi-Fi controlled LEDs and other automatic traffic lights. So what are the different types of components? So everything will be connected to the internet only. So initially, the day by day, we are the technology become evolution. So and also based upon this, that we will use the more IoT device to simplify the work. So when you are using a like Bluetooth earbuds, it is also an one type of IoT device. So what it will do, the communication technology which is used in the Bluetooth is Bluetooth. So by using this Bluetooth communication technology, we can send the data from one device to another device. Like in daily life, you will use debit cards, ATM cards, and credit cards. So it will use the NFC, like near field communication technology. So and also you can see the toll gates, when the vehicle enters, the automatically the door will be, I mean, what is the toll gate was there, it will automatically opens, and it validates the RFID tags. So the vehicle contains the RFID tags which contains the vehicle information. So like that, we will use IoT in different types of patterns, and by using the for complex problems, we can easily use the IoT to detect the uh, most crucial problems.
Dear students, uh, as time is running fast, we are concluding the session.